Excellent. There we go. So Llewellyn Falco learned to jump horses in the 7th grade while living in France. Back in the States, while studying drafting in high school, he started fire eating, sleight of hand magic, and once rode a unicycle 6 miles. After learning to juggle torches, he joined an acrobatics group in college where he specialized on the trampoline and walking a slack rope. He can calculate the cube root of any perfect cube under 1,000,000 in his head, as well as pick a standard lock. He can rollerblade down a flight of stairs backwards. Later, he learned to play the dombek, a type of drum. How do you say that?
Doombek.
Doombek, to accompany a belly dancing girlfriend. Llewellyn studied Tai Chi for 2 years, can throw a knife at 20 feet and a playing card at 50. He's taught swing dancing and loves to salsa. He's also an accomplished speed chess player. He's been scuba diving over 20 times, became a guitar hero, and broke his personal record of paddleballing over 200 times. Llewellyn attributes his success to the large amount of caffeine he has consumed and enjoys computer programming in his spare time. On a personal note, I met Llewellyn in, I want to say the summer of 2018 at UberConf, and was fortunate to go through a day-long workshop there, and have been through at least one other day-long workshop and heard him speak in a couple of other venues. And so I'm really excited to turn the time over to Llewellyn for micro API design with Consume First.
Thank you. I should share my screen.
And let's make sure that you can do that.
I did something bad. I'm gonna try again. There we go. Okay. There we go. Okay. Hello. I'm Llewellyn Falco. And for the past 5 years or so, I've been looking a lot at microskills. All right. So doing sessions where we take a very small skill and we go very deep into it. And that's going to be what this type of talk is about, right? Take a very small piece of thing that we do in code, and we're going to go much deeper in it than seems reasonable. And so I want to go way back to college. I had a friend, Ari, who was a English major. And at a party, I remember he had just started playing around with programming. And he said, you know, the beauty of poetry is that you can have the same poem and it expresses a million different things to a million different people. He's like, but the beauty of code is that a million different people can express the same thing in a million different ways. And that's what we're going to look at today. We're going to look at how creative can we be in the way we express code, and what are the implications of that creativity. And there's a pattern that I use a lot called the testing circle. And the idea here is we're going to write some code, like a test scenario, on a whiteboard, right? It doesn't actually have to be a whiteboard, but some way that we're not constrained by anything. We can express what we need really easily, right? So usually that means like at a whiteboard, right? Because just sketching on a whiteboard is a very powerful medium. And then once we have that scenario flushed, we're going to turn it into English. And then we're going to take that English and we're going to turn that English into code, which will eventually produce a result that will remind us about the whole thing we did on the whiteboard. Right. And we're going to look at just sort of one little section of this pattern right now, and that's taking the English and turning it into code. So what is this thing that we're drawing on the whiteboard? So we're going to draw a Battleship scenario. So Battleship is a game that you probably played as a kid, maybe even as an adult. It's a great game. So step number 1, we need a board. I don't like symmetry in my boards, so I'm going to make it non-symmetrical. Right? I don't like, sorry, it's not that I don't like symmetry in my boards. I don't like symmetry in my tests, right? Because you can invert two things. If they're the same thing, you can get it wrong and not notice. So we're going to make this 11 by 9. Oh, there we go. So we're going to create this 11 by 9 Battleship game. We're going to put one of those 3 ships. I believe it's a destroyer. here. We're going to start it at 4.3 and we're going to have it heading south. And then we're going to put a second ship. This is the aircraft carrier. We're going to put this at 2.1. We're going to have it heading east. And then maybe we're going to drop a bomb here at 2.3. That, of course, would miss. And then we'll drop another bomb at 3.1, and that would hit. And I mean, that's a good scenario, but that's way too much. Let's scale it back. Let's just deal with, let's create an 11x9 battleship game. That's going to be the entire story. So here's the rules. We are going to take that line of English, create an 11x9 battleship game, and we are going to turn it into code. We're not going to code the code underneath it. We have one line of English. We're going to turn it into one line of code. Now, the first rule is use your imagination, right? This is a generally good rule in programming, like write the code you want to exist. It's a variation, I think, of like be the change you want to see, right? Write the code you want to exist. So you don't have to like put ugly, like if you want array.first, just say array.first. You can underneath array.first do this other piece of code, but we're not even going to do that. We're just writing the first line, right? There's going to be no implementation deeper than that. And then the second part is I want you to evaluate the consequences of that line of code. And in fact, that's going to be the vast majority of this session, is us evaluating the consequences of code. So we're going to need some code to evaluate. This link is in the chat. I want you to go there. And when you do, you will see a Google Doc. Let me put some blank lines in here. So it just, oh, that did not do the blank lines I was expecting. Right. Thank you, Google. There we go. Lots of blank lines now. What I want you to do is at least one, but don't stop yourself at one. Go for as many ways as you can of translating, create an 11x9 battleship into code. And when we're all done, I'll try to give you a couple lines, one or two ways of writing it that nobody came up with. So I'm going to give you, I'm going to put 6 minutes on the clock. See what we can come up with. Right. In terms of language, I don't care what language you write it in, even if it's not a real language. We can all figure out stuff regardless. But this is a .NET group, so I'm expecting to see a lot of .NET compliant code. All right. So we're seeing some structure stuff. We're seeing some method stuff. We're seeing dimensions. We're seeing some container objects. What else do you got? Oh, there's many more ways than this. Should easily be able to get 20, 40 versions. Sorry about that.
So I know we just had a couple of people pop on.
Yes.
And so
I'll give another quick summary of where we are.
Yeah.
So there's a link in the chat to a Google Doc. And I want you to go there. And then the line of code that we are trying to translate, the line of English that we're trying to translate, so, excuse me, is on line 4. Create an 11x9 battleship game. What I want you to do is write that in code in as many different ways as you can imagine. Like, just try to be as creative as possible. One line of code only, right? But one line of code that will create an 11x9 battleship code. And you can see here we have like some rather straightforward things like a new battleship of 11x9. Here's one that takes a dimension. Here's one that is using like a builder pattern. Here's one which is just a function, right? Simple function. Here's one where we're making an array. Right? So the 11x9 is like outside of the thing. I want you to come up with as many as you can. When you're done, I'll try to give you a couple that maybe you haven't thought of. And we have a timer set for this exercise, which has another 2 minutes remaining. One minute left. All right. I think that's probably a good place for us to take a look. So first of all, thank you for all the suggestions. Let's start at the top. So I mentioned that like step 1 is use your creativity, but then step 2 is evaluate the consequences. And so for the next part, I want to start looking at these and saying, you know, we'll start here at line 5. Board equals new 11.9. What is the architecture that is implied by this? Right. And I've seen a lot of these already. So I have things, they might not be exactly right, but let's take a look and see what we can find. Not that one, not that one, that one. or that one, or that one, that one. Nope, 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 nope. Maybe I don't have this one. I don't have this one. Ah, nope. Okay. We're just going to have to diagram it out first. So the first thing is we know that we have some class called board, right? We're creating a variable called board, but we are calling it through a function call, an interesting function call, new, right? If it was lowercase, it would be a reserved word. But since there's an uppercase, we know that this is just a method call, right? Probably a static method being exposed somewhere, possibly a static or a member of the test itself, right? But this method returns a board. So we have some method called new. It takes an 11 and a 9, so 2 integers, returns a board. This has a couple really nice things. I have something very close to this. Let's go up to about here. So if we take a look at this, here, I'm stating where that method is. So instead of that method being called new, it's being called create. And I'm listing which class this method is on. That's not the case in here, right? So in here, it would look just like that. And instead of calling it create, we'd call it new. Now we have that scenario written down. But the architecture looks very simple, right? We have some method, takes 2 integers, it returns, what does it return? What's really tempting to say this method returns a board. But that's actually not true, right? It returns something that is a board, right? Which means this method could return something that extends a board, right? Which is an advantage of a factory pattern. We're going to evaluate all the code here, but I really don't want to. I want to try to avoid as much as possible evaluating the code in terms of good or bad, right? It's better to evaluate it in terms of consequences. And then when you look at how those consequences apply to your context, you can evaluate if it's good or bad, right? But here, by saying new, what it allows us to do is return something that extends a board if we want to. It also has the advantage that it's very short. It's straightforward. It's easy to read. It's very, very similar to this. Var game equals new battleship. However, here, this returns a battleship. It cannot return something that extends a battleship, right? So we've lost that piece of flexibility. But on the other hand, we have a constructor. We're fitting a very well-known paradigm. It's very simple and it's very straightforward. This comes to the same thing, except if this is Python, this might be instantiating a new board and storing it as a battleship. If we're in .NET, this is a method call, the same as line 5. We're looking at the same.
I can't tell you that I was thinking Python on line 7. I think line 7 was mine. So,
okay. Yeah. Allowing it open to all languages gives us this flexibility of analysis. So here we have a Battleship game create with a new dimensions. Let's go take a look at that. Here. Okay. So here we're creating a new battleship, and it has a new dimensions. Now here, in this example here, I'm saying new battleship, but I think the example that was written is doing a battleship game.create. So it's using factory pattern again, which means that it is now allowed to return something that extends battleship, right? Whereas here, because I'm using the new, that's not there. But the interesting thing, or the interesting difference here to me more is the fact that it takes a new dimension of 9 by 11. Right? And what that means is, first of all, it means we have 2 classes. We have the dimension class and we had the Battleship class. And it means that you can now extend dimension, right? So this doesn't have to take a dimension. It has to take something that is a dimension, meaning you could pass in a 3-dimensional object here, right? The Battleship game may or may not know how to handle the 3rd dimension, but you have the ability to do polymorphism on the dimensions, something we haven't had until now. Underneath it, we have something that looks very, very similar, right? We have a new Battleship game. Here we're passing in an anonymous object, which is a very interesting choice. But maybe we're in a duck-type language, something like JavaScript or something like Python.
Llewellyn?
Yeah.
There's a new-ish C# feature that lets you not specify the type and have it infer from the context.
Oh, no
Right
way.
there. Yeah.
Like var, but on construction.
On anytime you're instantiating an object where the type is known.
That is fantastic. So this might be almost identically the same as line 10, where you're creating a new dimensions. It's just syntactically sugar and pushes it away.
Yeah. Although I don't know if I got the syntax right, but that's what I was thinking of.
Nice. But so the other thing you're doing though is you have a width equals 11 and height equals 9, which is an anonymous property setting, right? And the interesting thing about that is it means that the dimension object would have 2 properties. One is width and one is height, right? Have this drawn out to here. No, do I have that right? I do not have that right. I have this right. All right. No, that's not right. That's hash map. Okay. This is not exactly right either, but the point that I'm looking at here, because here we're not passing in the dimensions, we're just creating a game with width and height. But it does mean that we have the width. It does mean we have the height. This has some interesting connotations, right? One is, while this is valid code, oh, sorry, let me do it that way. This, where I switch the width and height, is equally valid code. Where if I was to switch the 9 and 11 here, I now broken my code. So you have a bit of robustness there. It also gives you the ability to know, like, what does 11 refer to? What does 9 refer to? However is a wrong word. Let's just say it also allows for this code. So we can set the width and height, but we don't have to. We could only set the width, or we could only set the height, or we could set neither. It would also be valid to write that code. So we now have added optionality into our parameters.
I want to add another example here that looks like 11 or 12, except that instead of height, the person writes height, which is a common, say, alternate pronunciation of height. And
is it spelled differently?
Add an H at the end. I can imagine, or swap the T and the H. I can imagine somebody hearing that over and over, writing what they hear, having the code compile, but then not work properly.
So would this compile? I don't think this would compile.
Not if it's type.
If it's property.
Yeah, but if someone, for anonymous objects.
However, very, very similar to this code. Would be this code.
Yeah.
All right. So what's happening here is we're passing a hash map. And you'll notice that this code is so similar to the other code, right? And now what you're saying is a very real possibility. Someone could mistype something, and instead of getting a compiled, so like an architectural decision of here, or a consequence of here, is that people can mistype things. They can pass in values that you did not anticipate, or that you do not want. That's also a strength, right? People can pass in things that you did not prepare for, and maybe you're passing it on. So now you don't have to be as rigorous. You're sort of like future-proofing yourself a little bit. But it also means you have to do some validation. But then there's one other thing, which is, since this is just a hash map, if we look at the method signature just up here, this game hash map, right, or game dictionary, since we're in .NET world, it's very confusing, right? Like, what goes in that dictionary? So I'm going to need some documentation somewhere. Like, a consequence of this architecture decision is that somewhere I need to document something so people have some idea what to put into this dictionary. Another consequence, of course, is that people can put in things they don't mean. You're going to have to do some sort of validation, but also that this API will stay exactly the same, and you can extend functionality. You can add new parameters without ever changing the API. That is a nice advantage. And in fact, this is effectively how all of the web works, right? You call a URL and you pass it a bag of stuff. It sorts it out. Here, we have board equals new location, 11 by 9. So we're making an array. Meaning we in all of the things so far, we have ended up with one instance of Battleship game, right? It has different names, but one instance of an object. Here, we end up with 99 instances of location. And at the moment, they do not know about each other. In fact, at the moment, we don't have 99 instances of location. We have 99 nulls that are of type location, right? But we have an array of this grid. So we've now moved a lot of the logic to the outside, right? Locations, of course, is a nice way of saying this. The way I think I have it in here is to go even simpler. And just go straight to, nope, I must have gone past it. If only I could predict the order people would put things in. Just do it straight in ends. All right, just make an array of ends. And the interesting thing about this is there's no real architecture implied in here. In the one that we have here where we have location, at least we know we have a location class, right? But we really don't know anything if we're just using ints. But there is still an implied architectural decision, which is there's going to be something that does something on a double array of ints. In the future, there'll be something that takes a double array of ints and does something. And likewise here, there must be some method that's going to take an array of locations and do something. An advantage of this is look at how simple this is. Like, if you wanted to store this in a database, it's already set up. If you need to serialize this, send it across a wire, have someone else deserialize it, like, you have distilled the data to its essence, right? So you have like a sort of smart data, dumb methods pattern. There's a lot of advantages to that. A different variation of this just data aspect is if you look at like Linux command line, everything goes in and out of the Linux command line as strings, right? It's not like something we normally want in our code, but it's something that works really well for interoperability. Right? I know what's coming in. It's a stream of strings. I have to figure out how to parse that and do whatever, but like the format is well known. The intelligence of it is gone, but the data is very understandable. Very similar thing here. We've just now reduced a piece of knowledge one more time, right? So here we have 11 by 9. Here we have 99. And so there's some inference here, right? For example, we're inferring that it's 11 by 9 and not 9 by 11. Right? I'm trying to think of like other variations of that. 3 by 33. If I was better at math, like I'd give you more variations. I don't think 11 divides. It strikes me as prime. It could be 99 by 1. That would also be a valid board, right? So there's this implication of how it's being divided. And that either could come from just standardization, like it's always 11 by 9, or it's always 11 by something, or it could be something that we store in some sort of global registry, right? So I have this and somewhere else, the width or the height is being set. Very, very similar to this is list. The interesting thing about a list, of course, is that it's expandable. And at this point, it has no information. The 11 by 9 is not in this code. But it still has the same implication that we have a helper method somewhere that is going to act on a list events. Here we have a builder pattern. So new Battleship builder with height of 11, with height of, or with width of 9, build. This is an interesting one because it's the same code, but it can have a couple different implications in how it's going to show up. Let's see, where's our builder pattern? Here. Okay, so one is we can have a Battleship builder. Oh, interesting. This one has a dot build. Oh yeah, this one has a build too. Okay. So so here I have a Battleship builder. I have a Battleship class, the thing that is being built. I have a method rows and columns and builds. This has a couple of things going for it. One is it's much easier to write. I just have this Battleship builder. I can mix and match. I could say dot rows, dot columns, or I could say dot columns, dot rows. Also, I could just say dot rows, dot build, or just Battleship builder dot build, right? Like I could not do all the things that are needed, right? Or wanted. So maybe some validation at the build step that I've got everything that is needed. However, the exact same line of code can have a very different architecture, right? So it could be that when you call rows, you get a brand new class. So the only thing you can do on Battleship Builder is rows. And the only thing you can do on the result of that is dot columns. And the only thing you can do off of that is build. And that gives you a Battleship. And this is the same line of code. Like you could architect this exact same thing in a different mechanism. Now, this is more complicated, right? I have 4 classes where before I only had 1. But it does have an interesting effect that I now need a rows and a column, right? If I did only a dot rows dot build, it would not be a runtime validation error. It would be a compile time validation error. Right? This code tells me that these 2 things are required, and more often that they are required in this order. And of course, you can do mix and matches of this, right? I could do it where say, here I have a whole bunch of optional parameters, but if you give me a width, you then need to give me a height, and then I'll kick you back to a builder, and you can put whatever you want on it. All right. So instead of columns only having build, columns could kick me back to a Battleship builder. Battleship game. This is interesting. because there are no parameters. Where's my 9 by 11? Well, there's a couple different ways that might show up. Where are we looking? Somewhere around here. Here, new Battleship. Obviously, we need 11 by 9. Like that's the English that we're translating. So if this translates 11 by 9, those might just be implied things. Everything is 11 by 9. It's also possible that we read that from some sort of global state. Maybe we read that from a configuration file. Maybe we read that from a database. Maybe we read that from some sort of global memory state, right? It feels a little weird doing this in Battleship, but if I was just to slightly rewrite this, all right, so here's the other way it is. There's some sort of global configuration that includes the width and height. The Battleship goes and gets. However, if I rename Battleship to chess, this seems like a completely reasonable API, right? Because now we're taking things as defaults where there is a reasonable default, right? A chessboard should be 8 by 8. I don't want to pass in these weird dimensions, right? So making something default, again, like it's not a good idea to think of this as in terms of good or bad, like until you have your context, right? But making something default, if there really is just sort of a default, is a great idea. Making something where it's default where there isn't like a standard default is more confusing, right? The code is, oh, sorry, go on.
I was going to say something that I thought of when you were with the chess example is creating the board is obviously the same in even in other variants of chess. So if you're playing, Fisher random, for instance, so
removing variability where you really don't want variability, great decision.
Yeah.
I don't think we have this example, but while we're on it, let me go and show another variation of this. New Battleship level.easy. So this is somewhere in between those two states, right? So now, like in the first one, we say like Battleship 11.9, we have infinite variability. We have even more variability if we pass in a dimension, right? Battleship dimension 11 by 9, because now we can overload dimension to make a 3-dimensional board. But if we take away all of it, we get Battleship with no parameters. So now everything's a default. Here we have battleship.level.easy. And this is really a nice decision where you want only a finite set of variables. Right? In this case, I have 3, easy, medium, hard. But if I have just I have a finite, like a small set of what the variations are, this can be a really nice way to do it, right? So to say, hey, I've prepackaged these variations, choose one, but you can't just choose anything. If I make this an enum, it's possible level is a class, right? In which case I could extend level and do something completely custom as well, effectively packing in or passing in a preconfigured config. Like when I go to the pizza shop and say, give me the meat lovers pizza, right? But I can still build my own. All right, where have we gotten to? Create a board. So we have factory pattern here, new Battleship rules, and a new size. I don't have this exact one, but I have something very close to it. Here. So here I have a game creator.create 11.9 and game type Battleship. So here I have a game type as opposed to a rules class, right? And I'm passing in the 11.9. I'm not packaging it up into a container class. But we're seeing similar things, right? And this has a really nice thing. Like it implies, by the way, that the thing I get back, this game, is a base class, like a more abstract thing, meaning that this new Battleship board means that we probably could do something. Oh, that's not what I meant to do. Right? Where it's like new checker rules. That one probably has to be a little symmetrical. Right? And now I get back a checkerboard. So this architecture allows me flexibility in the types of games that are coming out of this constructor. Right? Meaning if I was in context where I had a whole bunch of games and I wanted sort of a centralized creator to it, this would be a really nice architecture. Like I've added some complexity, I've added some abstraction, but that abstraction allows for flexibility in the type of game that is being created. What else do we got here? Oh, beautiful. Okay, so here we have a new Battleship game. It has 11, it has 9, it has 5 ships and 2 players. Pieces that are definitely not in the English. I have a variation of this as well. I think my variation might be a little bit less pretty than this one. But here's a different variation of it. So I'm making a new Battleship. I have the 11, I have 9, and then I have a whole bunch of other variables that are not needed. Right. This is a design that I see very often in industry. Right. I want to create this class. It has 15 fields, and therefore I have a constructor that takes 15 things. Right. The nice aspect of this, the reason I see this in industry so much, is that I only need one constructor to do everything, right? If I stretch the definition of minimalist design, it's minimalist. Only one constructor takes all the parameters. The downside to this is that there's a lot of things I don't care about that I have to put in there. And in fact, you know, just as we have here where it's null, null, for this board, you might see somebody very validly write this exact same line of code with just null, 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 null. Right? Basically the exact same line of code we have above. Just nulling out all the things I don't care about. And therefore making it very confusing as to what these values even are. The nice thing about the named variables that we see showing up here is it gives a good indication of what these things are that we don't care about. Or at least don't care about in this scenario. But like I said, I see this kind of code all the time. It does have the advantage of just one constructor to rule them all. This is extremely interesting. I almost have this example. var game create Battleship 11/9. So I want to point out first, because what I'm about to show you is not going to resemble this at all. So I want to point out what the architecture of this is before I show it to you. So I have a function that takes a string that returns a Battleship game. Does that make sense? Function takes a string, returns a Battleship game. So I also have one here. It's a function. It takes a string. It returns a Battleship game. You might notice that my string is very different. Instead of 11 by 9, I've actually like enumerated the entire board. But that's an interesting aspect of this kind of design. If it takes a string, it can really be any string. It's sort of up to your parser as to what it takes. Obviously, the parser for 11 by 9 is going to be a little bit easier to write. But as with all parsers, you'll need to do validation on it. And the other thing is you're going to need to do documentation, right? Since create Battleship game takes a string, looks exactly syntactically the same as load string, how do we know that this string needs to look like this and this string needs to look like that? It's got to be some documentation somewhere. It also gives you a lot of flexibility, right? You could make this function take either. Your parser detects that it's 11 by 9 and kicks you back an empty 11 by 9 board. It sees the dots and the new lines, and it kicks you back a populated 11 by 9 board, right? So you can have a very robust parsing at this level, right? You're putting some design logic into your parser, quite a lot of design logic into your parser, but that's okay. I mean, again, like this is how the web works, right? Give me some HTML text and I will parse it and do stuff. This allows you a lot of flexibility going forward, right? If you wanted to make it 3-dimensional, you could. No changes to your API, right? Technically, it would be a patch upgrade to add 3 dimensions into it. This is also where this would be really useful is in my test classes. I could very easily see writing this function for my tests. Right? Hey, I need to set up a starting state like this. There's also sort of an implied function somewhere that probably writes this, right? Given a board, serialize it to this thing that I can deserialize here, right? It might be really nice to have a log statement that prints out a board like this if something goes wrong, so I can easily consume it and reproduce what went wrong in my logs. This concept of like serializing and deserializing your state of your program is being built into the architecture here. Let's see what else we got. Board 11, this one we've done. Grid, we've done. Game config, we have not done this yet. We've done some variations on game config. So let's go up here. We didn't do this, that. Oh, we haven't talked about that one yet. So we've done something like this, right? Where it takes a hash map. That could be what the config is, right? And of course, we also did where it takes a specific config object, right? If you remember, we had one where the thing it took had a height and a width as a property. I think it was a dimension at that point. That's a more narrow version than just any config, but it comes to sort of the same thing. Here I have it as just args. So I'm creating a new game with args. That's my config. It's implied that that config includes a width and a height, but it's open to including other things, right? So that config is very expandable. Right, so I've built in that sort of expansibility. That's not a word. Expandability into this architecture. I've added a little bit of extra complexity, right? It is also possible I could override game args, though for a config, it would be unlikely that I'd override it. Battleship game, trim ended. Yes, so this is actually very, very close to what we were looking at right here. Where did that go? Here, right? So here I have a string. I'm doing a multi-line string. I'm putting a trim indent on it so that I don't have to worry about it looking ugly and making my code all messy. But yes. Battleship should have width 11 and have height 9. So we're back to builder pattern here, a little bit nicer English. Some very interesting things here, like and has to be a property.
Well, and this isn't builder, this is assertion.
Oh, you're doing an assert.
Yeah.
But it has to, if we're translating creates a battleship game, have height 9 needs to return a battleship. Or somehow a battleship game has got to be created.
Yeah. No, it doesn't store the battleship anywhere. It creates it and then asserts that it has those dimensions, and then it's done.
So really, the creation part is just here, new battleship. And then we've just added some extra stuff that's not in the English.
Well, yeah. I mean, it says that the rest of the constraints in the English are present, but those constraints exist elsewhere.
Yeah. All right. But I still want to point out, and not having the parentheses has to be a property of whatever object have with gives back, and has to return some sort of object that has a method on it of have height. If these are assertions, then probably they also throw exceptions on failure. All right. I have a couple others that we haven't touched on in here. So let's go through and take a look at what other ways of doing this we haven't hit on. We've done that. We haven't done this one. So this is new rows and new columns. This has an interesting thing. Well, so first of all, we have 3 classes. We have the battleship, we have the rows, we have the columns, right? It has the interesting effect that if you switch the rows and columns, it doesn't compile, right? So now we're sort of moving away from primitive accession. We've added complexity to get there. It also allows us to extend rows and columns, but it doesn't allow us to add a third dimension, right? So like while we've added flexibility in the 2 pieces, because we've broken up the 2 pieces, you can't add something around the 2 pieces. Whereas what you could with dimension, we've looked at that already. We looked at this already. We looked at that. We looked at that. We've gotten most of these. This is slightly different again. So here we are reading in state from an external resource, right? So we have a battleship loader, reads a CSV file. We give it the name of the file. This implies that we are hitting a file system, but of course, that's not necessarily the case. That could be a URL, right? And so that we hit some sort of server or some sort of server command, period. It's even possible that the string could give you some sort of key that we look up, right? I mean, technically speaking, a file name is a key that you look up. We've talked about builders. This is also a builder pattern. Create a 9x11 battleship game. Just slightly different architecture. Create a 11x9 battleship game. Just look at the architecture here being slightly different, right? Create ends up with 2 functions instead of 1. They become tied, but they also become independent. We've talked about this. AutoWire game. This is what I see in spring projects around the world. This tells us almost nothing about the architecture of anything. We know that there is a game class. We know almost nothing else. But the really nice thing about AutoWire is that if you have, if you want to make changes to your system post compilation, you can. Right? Why you would ever want to do that in a web service is beyond me, as you never really want to change a web service after you compiled it. But for example, it is this mechanism that allows for plugins into Chrome, right? This is what allows you to modify Chrome's behavior without having to recompile Chrome. That's a super useful thing. This is the kind of code I would see in a C++ or an embedded C project. Start Battleship. It is a method. There's obviously some sort of global state. It does not return me an object. It does not take any parameters. It just starts the Battleship game. All right. These functions are really, really useful if you have really, really limited memory and stack space. Which is why like it started in embedded C, where you're like, you've got 5K of space, and that has to include your program as well. It's not as good if you have more, because it takes away a lot of readability, right? Like, I don't know what parameters are coming in here. I don't know where they come from, and I don't know what the result of calling this is. It implies that it starts the Battleship, but that must do something to some state somewhere globally. What state is it doing it to? I don't know. This is moving a lot towards global state. We've talked about this. Sorry, where did it go? Went too far. Okay, we did this one. We've done this one. We've done this one. We've done this one. Create an 11x9 board. Very easy to read. Notice we've encoded the parameters into the method name here. Again, this can be really useful if you have very limited options, right? You could imagine a create easy board, a create hard board, and a create medium board. Instead of passing in the three things, you just call the method. It's a little bit stranger to do on things where you would have a lot of variation, but you don't have to do any error checking. You don't have to check that someone passed in a -5 for a width. That's not going to happen here. Most likely, though, this also implies a second method that it's calling out to, that's just hidden from your view. Just to extend encoding parameters a little bit stronger, you could encode them into the method. You could also encode them into the class, right? We have an 11x9 Battleship game. It extends Battleship. And then finally, we are now in a cloud connected world. We could just be calling out to AWS and saying, start a Battleship game. By the way, that's another advantage of the create Battleship game with the global state. I see that in embedded C a lot, but I also, of course, see it in web APIs a lot. I'm going to call my server and say, create a Battleship game. Maybe it gives me back a token, or maybe it just starts one up. That's another advantage of embedded state, right? That state is being managed completely by something else, which means it is safer. Safer is a weird word to use for global state, but at least you can put a layer of protection around it. All right. Well, that's sort of all I have for you tonight, but there's a couple of things I want you to take away from this. The first is, when I first realized that code could be written in multiple ways, it was a bit of a surprise for me, right? Like Ari and I had that conversation a long time ago, but I mainly just left that conversation saying, yeah, well, there's like a right way to write the code and a lot of dumb ways to write it. It wasn't until later that I started to realize that, like, when I look at the English and I turn it into code, I'm just turning it into the way that is obvious to me at the moment. Right. But there is actually just a ton of variation. And that, if you take nothing more away from tonight's talk, I want you to take that away. That for every line, even a simple line of code, like create an 11x9 Battleship game, there are a myriad of ways to implement that. And they have different consequences. And that's the second thing I want you to take away, is when you write code, right, look at what the consequences are. And you don't have to say these are the best consequences. I just want you, if you look at code and you look at the consequences and you say, I don't like those consequences, for you to then go back and change the code you write. That's all I got for you tonight. Thank you very much.
Thanks. So we're going to open it up for anybody who's got any questions for Llewellyn.
I'm going to need to take just a 1 minute pause before I answer those questions. Excuse me for 1 moment.
No worries. I guess this is where when somebody has come back to watch the YouTube later, you can just skip forward for the next 60 seconds here. I'd also say, lots of people had their cameras off. I saw Jay nodding his head quite frequently at the same things that I was nodding my head at. I maintain one of the things that I do. I work in a group that has around the whole company has about 250 developers. Over the years, we've accumulated, I think at last count, they said roughly 1,600 individual projects. Lots of little websites, things like that. I work in a group that drops in and out of a lot of old C# and even older VB and VB.NET projects. I see a ton of methods that have 16 parameters, and they're called with function, or they're called with variables that have 1 or 2 letter names, and yeah. So I'm a big fan of naming things well and simplifying what you're passing around. Replacing all of these parameters with an object that holds all that data and things like that. So that was one of the things. And like I said, I saw Jay nodding his head on some of those same issues. So.
Yeah, that's not always a good pattern to have lots and lots of parameters, but it is a common pattern.
Yeah. So somebody from on the YouTube channel that is a good friend of mine was sending me text messages during the presentation, and one of the things that he brought up was one of the things that you can think about is comparing some of this. Some of the method design and class design to how you would do your database normalization, and thinking about how Boyce Codd would design a Battleship class.
Yeah. Yeah, most of the stuff we saw hid the data behind the object, which is a pattern that I enjoy. We did see stuff with the double array, which is sort of pushing its data implementation more to the forefront. But yes, when I design databases, I think about the same things.
Yeah. Another point that came up was using this type of discussion as a good starting point for interviewing people. A lot of times I know in the past when I've interviewed people to become members of our teams, we've come in with a specific problem or even a specific code sample, and this seems like a really good technique to just say, hey, for 5 minutes, let's just brainstorm how to do one line of this thing, and then we're going to spend the rest of the interview just talking about what this implies, because so much of what many of these examples implied, it was, I guess, opaque to me before we started talking about it.
So outside of whether or not this is good for an interview, although in general, I like interviews that have you do things that you would do in work. So the more you get to see someone work, I think that's the better an interview. What I don't like about interviews is surprises, right? Like I don't like oh, this person looked really good in an interview. There are like all these sessions that are like how to interview better. I feel like if you can interview better after studying for a night, the interview itself is broken, right? Like, because like this is like a long-term committed relationship that you're entering to with a company, right? Like it should be something where it's like, you know what you're getting into and they know what they're getting into, and it's good for both of you. And anything short of that is sort of a failing of the interview process. But that aside, I think that these discussions are good to have, period, right? Whether you're doing it with an interviewee or just your fellow coworkers in general, it's something that I noticed doesn't happen a lot, period, which is why this entire session came out, right? Because a lot of times, like when I would see people write stuff, and what usually, like for me, the thing that would trigger it is they would say, well, I don't want to write this code. This is bad code. And I'm like, okay, well, then why did you write the previous line of code? Right? Like these are consequences of you writing that line of code. And they'd be like, well, I was forced to because of the English. Right. And so that is where like I start to realize, oh, most people don't realize, like they don't realize at the time they write the code that they've already set something they don't like. Right. Which is, it's so easy to refactor code when you haven't written the implementation to it. Like rename is super easy if you've written a method that has not existed yet. You just change the name and you're done. Right. Like you can do really powerful refactoring when you consume it first, right? You can say, hey, like, I want this to exist, and then be like, oh, I actually don't want that to exist. Let me fix it. So it's almost akin to like making a wireframe as a designer, right? It's like, hey, we have this frame of what we think the page should look like. Now we're going to fill it in. It's like, here we have a frame of what our code needs to look like, and now we're going to fill in these classes and these methods and these properties. So if you're going to do that, you need to take that moment to evaluate, do I actually like what I just wireframed? Right. And I notice people don't tend to do it. And just like everything, you know, skills are things that you practice and you get better at. And if you don't practice them, you don't get better at them. And so having these conversations, I think, is valuable, period. Right. And having enough of these conversations that you can do this analysis almost in the background without putting conscious thought into it is really good. Right. Like you want to be able to just look at a piece of code and be like, I don't like that. Or look at a piece of code and say, yeah, that actually fits what I'm trying to do. So I think these conversations are really important. And I also think that they're not happening. So any way you have more of them, I am happy. Do them in your interviews, do them in your colleagues, do them in your code, your pull request when you do a code review, whatever you want to do it there, but have more of them. You're on mute. Gary, you're on mute.
I clicked on mute twice. So Jay posted a GitHub gist in the comments. Jay, do you want to talk about that for a second?
Sure. Maybe Llewellyn wants to bring it up and share it.
Yeah. Let me share my screen.
Yeah, and I'll try to introduce it while you do. So there's a thing called fluent assertions, which lets you write kind of builder-like patterns for assertions, and it's extensible. So I threw that together to see what it would look like. Yeah, so you see on 11 is we're creating the Battleship game. We're asserting that it has the expected dimensions, but the expected dimensions they come from somewhere else that I'm not specifying.
Yeah.
So the fact that they're 11 by 9 is visible in the test, but the decision to make them 11 by 9, I don't know where that comes from. Just glossing over that.
I haven't actually seen this before. What's in it?
It's an init only property, so it can only be set in a constructor. And I'm suggesting that at 21 and a half is a constructor that does stuff, but who knows what it does.
Yeah. So it's sort of saying like this is read only in a property.
Yeah.
So but stronger, because it's like normally if I did that, I'd just put a get and make the set private.
Right.
But this is even stronger than that because the class itself cannot change it.
Mm-hmm.
Nice.
I was going to say, it sounds like we need to do a session in this group for what's new in C# 9 and 10, and then we'll invite Llewellyn to come back and learn with us.
That feels like something Jay should be hosting and I should be attending.
Init, I think is Init 9 or is Init 10? I don't think it was 8, right?
I think it's 9.
Yeah.
Yeah. Can you scroll back up to like line 11? So there's things that I like and don't like. That I'm okay with 11, 12, 13, but I'm kind of annoyed with how 14 works out. So each step in this process returns this useful object with wonderful capabilities. And you can see there's the extensions and the assertions and the and constraint and so on. So you were noticing before, hey, there's this and property. Where does that come from? It comes from the and constraint that's in the Fluent Assertions library.
Oh, so this is, sorry. So I was saying this is a property, but what you're saying is it's actually like an extension method.
Should is an extension
property
method.
Though. Yeah,
So
extension methods have to be methods.
That returns an assertions object and is a property on the result of have with. So have with returns an and constraint.
Do we have a have with here?
Yeah.
So this returns an and constraint of an assertion, and constraint has the and on it.
Yeah. So this code works, by the way. If you build it, it'll do the right thing.
So subject, what's going on here?
So subject, like that's short for test subject, the thing that we're asserting on.
And that's how we get back our Battleship game.
Yeah. And just because of how Fluent Assertion works, you have to get the and constraint object. So 14 and subject does not read like very natural English.
What would be better English? What would you like here? I almost want to say like should have with 11 and have height 9 dot get.
That get subject?
That would work too. Get subject.
I'm okay with get subject, but the first thing I notice is when I have a getter in C#, I think I want it to be a property. It was just dot subject. Like I'm lost again. So I don't know.
But the nice thing about dot get or dot get subject is that you could put it as an extension method onto and constraint, which is something we don't have control of in this current architecture, where you can't put a property on because there's no such thing as extension properties. There are just extension methods. Have you gone pensive or have you frozen? I think Jay might be frozen.
Yeah, Jay might have gone frozen. So
I win by default.
Yeah. Well, we have a comment from Ben Davis in the chat where he was talking about a particular pattern that we see with a lot of async code in C#, where he sees, await something configure await false in async code. Ben, do you want to talk to that point a little bit?
Yeah.
I mean, I can see you're on the call, but I can see you're muted. So,
microphone-less right now.
Ben is microphone-less. So, I don't know, Llewellyn, could you see that?
So there was a slide that I had here where I talk about the lots of parameters. Here, this one. So true, false, true. Like there's so much that I dislike about this. It's very concise, which is nice. But what is not nice is that like it's very easy for me to flip a true, false, true, like especially as this gets longer. Like, have I gotten the 5th variable or the 6th variable? Like it's very blurry. But the other thing is I have no idea what this true, false, true means, right? What are these Booleans asking? And I think that's what Ben is referring to in that statement of sort of like, it would be nice if the method name made it very clear what false meant, right? And it's weird because the method he gave, where is that here? Configure await false, right? Like it's almost like it almost feels like it should be like configure should await or should be asynchronous, or like if you just slightly change the name of that, maybe the false would be much clearer as to what it actually means. Oh, he has a J. Clear would be configure await to continue on captured context and not even pass in the parameter. So here we're taking the value of the parameter and moving it into the method name, as we saw by the like create 9x11 Battleship game. Yeah, but it's super clear. Yeah, I like that. And an excellent example of where moving a parameter into a method name like is enhancing the code to show one of its advantages.
Excellent. That's all the comments I see in chat. Does anybody else have anything they want to bring up?
All right, I think we might be at an end.
Excellent. So let's see. I think people should be able to see my screen again. So first of all, I want to thank Llewellyn for his time tonight. This was incredibly informative. This is actually the second time I've been through this particular presentation. It was definitely different the last time because we're just taking people's random code samples. And there are a number of things that I think it was much earlier this year, maybe January or February, and I've already forgotten much of what I had learned. So it's a great refresher for me. So thank you. I am going to first of all put into the chat. I think I've got this. I've got a link in the chat here, and it's the link up here, this tiny URL SLC prize. We do have some prizes that we'll be giving away here very shortly. And so this is where we give feedback to the presenter. So I encourage you to go out and please enter the feedback and let Llewellyn know what you thought of the presentation and any additional suggestions you might have. One thing that I want to point out on that feedback form is there will be a section there asking if you would like if you would be willing to do lightning talks in the future, and if you do, even if you think maybe, you can just put yes or no or maybe on that. And what we will do is a few days before our next meetup, we will send you a reminder email that says, hey, you said you might be interested in doing a lightning talk, and that'll give you maybe a few days warning to be able to put together some thoughts and share that talk with us at our next meetup. In addition, I'm going to paste two more links into the chat. The one will be they're in opposite orders from what's on the slide. One is for presentation proposals. So we're looking for presentation proposals for people who'd like to give talks to this group for the next year. And so you can go to the tiny URL /SLCnet and enter a presentation proposal. We're also looking to expand our organizing board. So if you would be interested in being a member of the board of this group and help make some decisions about the direction of the group and manage the group, we're taking applications to be a member of the board. And we want to thank our sponsors. So Health Equity and DealerTrack, the two local companies that have been sponsoring our group for a while. Tech Systems, who does sponsors contractors for lots of companies out here in Utah. JetBrains, who is providing two of our prizes. JetBrains is providing a coupon for basically any product that they offer or suite of products they offer, except for the all products pack. We'll be giving away two of those here in just a minute. O'Reilly, who is sponsoring us by giving us the opportunity to give you an ebook. So any ebook published by O'Reilly, we'll give away 2 of those tonight as well. And then the last thing on the screen, and I will paste this in the chat, is a link to the Manning website and a discount code. So Manning has graciously provided all of us 35% off anything that's not already 35 or more percent off. They're like a lot of online publishers. They're frequently running deals and specials. So unfortunately, it's not get 25% off and then another 35% off. It's you can apply this coupon and they'll apply the best code. With that, I think it's about time for